In this lesson, we're going to be factoring trinomials with the leading coefficient of 1. So what does that mean? So first off, directions are going to say factor, and there's going to be a certain look for each of our problems. Trinomial means we have exactly 3 terms. Leading coefficient of 1 means there's going to be no number in front of the x squared, or whatever the leading term is. So that's kind of our look every single time. So to factor this, we're going to try and turn this into what it looked like before we distributed, or what it looked like before we FOILed everything. So there are little hints along the way, and the first part of this is first times first, first, outer, inner, last. First times first makes x squared. So x times x. Then we have some hints to what we got going on. So the fact that that's a plus 24 is this means that whatever it's going to multiply to make 24, the signs are going to be the same. All right, so we need last times last to make a positive 24. So the signs are going to be the same. They're either both going to be positive or they're both going to be negative. So we'll list out our factors of 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And if we kept on going, we would start to get a repeat of that. So those are the factors of 24. So this is telling us that the signs need to be the same. So it's either a positive times a positive or a negative times a negative. This tells us they both need to be positive. All right, so a little bit of a hint as to what we got going on. So positive times a positive. So next part of this is last times last makes 24. Here's our list. And then the 11x is actually going to come from the outsides and the insides multiplied together. So first times first, we got that set up. Last times last, it's going to come from that list. So we have that set up. The OI on FOIL is going to be the outside and the inside is going to make the middle. So the middle of FOIL is going to make the middle of that equation. So we need 2 numbers that they're actually going to be like terms, so they're going to combine together. So we need numbers that are going to add to 11. The 3 and the 8 are going to work perfect for us. So if you multiply the outsides together, that makes 8x. If you multiply the insides together, that makes a positive 3x, and a positive 8x and a positive 3x makes a positive 11x, which is exactly what we need. So those end up being the factors of this expression. So let's do another one. So instead of having a positive 11x, what if we have a minus 11x plus 24? So first times first still needs to make x squared. This is telling us the signs are the same. This is telling us that they're both negative. All right, so we have a negative and a negative. We still need things that multiply to 24, and they're going to add to a negative 11. So these 2 numbers still add up to 11. If we just put a negative on the front of both of them, they'll give us exactly what we need. So if we distribute or multiply the outsides together, it's negative 8x. Multiply the insides together, it's negative 3x, which is going to make exactly negative 11x. All right. So let's do x squared plus 5x minus 24. So we'll set up our factors. This time we have a negative 24, so we still have the exact same list. 2 numbers that multiply to 24, but this time the signs are going to be different. And this kind of just gives us really more of an indication of out of the 2 numbers, the bigger of the 2 is going to be a positive. Because if the signs are different, you're actually going to subtract these numbers. So you're trying to find the difference between them. The difference needs to be 5. So you have a 24 and 1. The difference is going to be 23. It could be a positive 23 or negative 23. Depends on which one, where we put the negative. Here the difference is going to be 10. Here the difference is 5. Perfect. Exactly what we need. So signs are going to be different. And we need to add up to a positive 5. So we'll make the 8 positive and the 3 negative. So if we check that, we do the outsides, it's going to be a negative 3x. The insides are going to be a positive 8x, which adds up to a positive 5x. Perfect. All right, let's do another one. So we'll have an x squared minus 5x minus 24. Okay, same list. Here's our list. That's going to multiply to 24. X times x is going to get us x squared. Signs are going to be different because of this. And the bigger of the two is going to be a negative. So what's going to add up to a 5 again? These two still differ by 5, but this time the 8 is going to have the negative and the 3 will have the positive. So if you check it, we'll just check the OI part. So negative 8x and a positive 3x if you multiply the outsides and the insides together, which adds up to negative 5x. Perfect. Exactly what we needed. All right, so what if we have an x squared minus 2x minus 24? So same factors, except this time signs are different and they need to differ by 2. And then we'll just apply the negative appropriately. So x times x, we need factors of 24 that are going to differ by 2, which is this combination right here. So 4 and 6, one's going to be positive, one's going to be negative, because we know the difference. They have to be different with this being a negative 24. And we need more negatives than we do positives. So the 6 will be negative, the 4 will be positive. So first times first gives us our x squared. Our outsides give us a negative 6x. Our insides give us a positive 4x, which makes negative 2x. And our last times our last makes negative 24. Great. All right. Number 6. We're going to take x squared minus 9x minus 36. So we got a different factor at the end here. So we need multiples, numbers that multiply to 36. So we got a 1 and a 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So those are all the factors of 36. Signs are going to be different, so one's positive, one's negative. And different means we're going to subtract, and they need to subtract to 9, and then we'll just apply the bigger of the two with a negative. So which of these differ by 9? This is 35, this is 16, this is 9 if you subtract them, so they differ by 9. Great, and we need it to be a negative, so we'll put the 12 there and the 3 there. And we can check it by foiling it all out, and we should get back to the original. All right, one more. So if we have 3x squared plus 21, actually 3x cubed, plus 21x squared plus 30x. We haven't mentioned this at all on any of these problems yet, but actually the very first thing we should look to do is there a greatest common factor we can divide out of every single piece? Because this whole thing is supposed to be leading coefficient of 1, which that's not a 1. So by chance, is there something we can divide out of every single piece? We could divide a 3 out of all of the numbers, and we can divide an x out of all of the variables. So we'll factor a 3x out. So that is going to leave us with x squared, and then we'll divide a 3x out of that, so plus 7x, and then plus 10. Okay, so no different than before. Just don't lose your factor that you factored out at the very beginning. So what multiplies, your signs are going to be both the same, and it's telling you they're both going to be positive. Now we can get into what multiplies to 10 that adds to 7, and our answers are 5 and 2. So if you multiply these two back together, this would get you this. If you distribute the 3x in, should get you all the way back to the beginning. So all of these are the factors of the 3x cubed plus 21x squared plus 30x. And that is factoring trinomials with the leading coefficient of 1.